So hello, my name is Erwan Gouriou, and I'm working. I'm from ST Microelectronics. I'm working on Zephyr for mostly on STM32 parts. And today we'll discuss about board configuration. So why board configuration? So boards are an important part of Zephyr. There are more than 85 boards available, and porting all these boards and configuring these boards is a lot of work and generates a lot of reviews. It's an important matter as well because this will be the first contact for a newcomer with Zephyr. This will be the this will determine if he can easily run a sample on his board or if he will have some troubles to do it. Also, if we have an easier board configuration, we'll have some easier board to test matching, and more samples and more tests run on more boards will mean a more efficient CI. What do I mean by configuration? There are different levels. So the driver selections, for instance, if it's STM32 UART that you want to run, which is SOC dependent. The driver configuration, the driver speed, for instance, which will be application dependent. And last one would be the pin configuration, which is a bit SOC and application dependent. Since I'm more comfortable with STM32, I will say what we've done on board configuration for STM32 boards or base boards since last release. So we've tried to reduce the use of configuration flags to configure the boards because there were a lot of them and it was creating some confusion. So we first tried to do some STM32 specific stuff, which is moving driver selection bits from boards to ARC, as these were mostly dependent on SOC and not on board. Doing this, we've been able to factorize the configuration because due to the architecture of the SOC part, we are able to commonize some things. Then we beneficiate from Zephyr generic stuff, like device tree deployment, mostly from the last release on I2C and SPI, that help to reduce the configuration flags. And also we've been moving fix-up files, which are device tree generation artifacts, from board to ARC, so minimizing the need for configuration flags. Also, by reviewing a lot of pull requests, we saw that we need to define some rules for board configurations. Aim is to provide some objective rules and minimize discussions. So one rule would be to enable use of embedded hardware, like sensors, LEDs, buttons, communication interface. And when available, configure the board connectors. Like if you have some Arduino connectors on your board, configure the pin control to let it available. So we have some other rules like providing a default network interface. Then yes, that's it. So how we can improve further the board configuration? So first, continue device tree deployment. Next step would be pin control and clocks, which would be important, I guess. And eventually remove or minimize at least the use of fix-up files that are not really they are needed right now, but we should be able to get rid of it. Also, what would be interesting is to promote some bindings, to have some bindings available between the boards and the samples or applications. If we are able to define such binding, we will be able to use them in the samples on the applications. Like for instance, Zephyr LED 0. And if these aliases are defined in the boards, that means that for all boards that have defined these aliases, we will be able to run the samples quite easily on these boards. So I've done that for GPIO in pull request, and it works well. For now, it's working only for GPIO, but okay. One final stuff I would like to mention is the use of shields. So in microcontroller worlds on microcontroller boards, what is interesting is to be able to use shields, like sensor shield, for instance. Idea is to say that when you have a board plus a shield, it's just another board. So if you are able to configure the hardware which is available on the shield easily, if we can provide default configuration for this board, it will be quite easy to use. So for instance, we could store board shield configurations in a shield specific folder with shield overlays, kconfig.shields, and so on, and activate all this configuration with just a kconfig flag. Okay, so this is the idea. I've started a discussion on that on GitHub, try to make a prototype. This has a limitation for now, but I think this is interesting. So I'm done with my part. If you have some question, quick question, either you can come to me and discuss this matter. No question? Okay, thank you.
So I'm Gil Pitney from Texas Instruments. I'm an assignee into Linaro, and I've been working on getting our TI has a simple link family of SoCs, which has a network coprocessor, which offloads the complete TCP/IP stack from the MCU onto a network coprocessor. So I've been working to get that integrated into Zephyr. And so this is the current state of Zephyr as in what's in master. On the left is pretty much the networking stack of Zephyr. All the network protocols, WebSock, MQTT, LWM, M2M, DNS, etc., work over a data plane, which is pretty much, get this working. That work? Yeah. So net context is the interface for the data plane, and net management is the interface for the control plane. NetApp is a sort of a convenience layer that handles client server setup, TLS, and stuff like that over net context. So all the network protocols currently work over NetApp and net context. Net management is used for things like getting notification of network up, network down, things like that. So the core network stack, Zephyr IP stack, has an L2 interface, a well-defined link layer, and there's various technologies that are currently implemented in Zephyr, like Ethernet from various companies, 802.15.4, Bluetooth L2 cap. There's currently no Wi-Fi L2 drivers in Zephyr. There's no Wi-Fi control plane APIs yet. So the idea was, and then BSD sockets is something that's recently been added by Paul Sokolovsky here in the LITE team, and as a way to get third-party BSD socket applications ported into Zephyr. And that's a recent addition, and there's some Micropython socket demos that all work on that very nicely. So the original idea was that Wi-Fi would be added to Zephyr through this offload hook, through these offload chips like the TI Simple Link chip and other chips. Through a hook, it's called Vampire Tap, from the data plane net context APIs, hooking off into this TCP/IP offload engine. So that was that's the original plan. So I started actually implementing that a Wi-Fi driver off of this offload tap, and as I went through it, I realized that there were some issues there. One was that there's a lot of sort of impedance matching or mapping between the asynchronous APIs of net context and the synchronous APIs of the BSD socket API, which is what we use, Simple Link uses, and also this wasn't giving us the best hardware entitlement because there was a lot of duplication of network packet queuing, buffer management that we're doing in the offload chip that's also being done here. There's threads being created that we don't need. So looking at this, I said, well, let me see if I can do something a little more efficient. So I created a socket offload framework PR, which similar to what's done in Minute operating system, which comes right off of this new socket layer. And that actually worked. I made some demos at Connect, previous Connects, and but the pushback was, well, that's nice and good, but the problem is it's not making use of all these protocols which are going through this path. So, okay. And the other problem was it doesn't hook into multiple bearer support, so the IP routing table is involved at this level, it's involved over here. So in the meantime, other drivers appeared. Atmel driver, STMicro has a driver that's in PR stage. It's going to be worked on pretty soon. And also the network team started working on a RFC for a Wi-Fi management API to add connect, scan, and other kinds of things. And since one of the issues with this framework was, well, we don't have a lot of stuff working on sockets, I took one of the MQTT Zephyr protocols and ported it to sockets through an async socket layer that works with non-secure sockets. And then Paul came along and implemented a TLS API so that secure sockets could work, and he got MQTT ported to that. So all this works. So slowly we're going to be migrating some of these Zephyr protocols over to sockets. So let's see, bottom line is, so for Wi-Fi offload, it's all basically in PR states, all in these PRs. It's pending getting this Wi-Fi management upstream, getting, also NetBuff is being redesigned. Paul might touch on some of this. This will probably affect this stuff. As this migrates over to here, there'll be more apps on top of sockets, so this framework may make more sense. So it's all a bit in flux, and that's kind of where it is. So last slide is a list of the PRs that are in play, and the last presentation is one I gave last year on doing offloading in Zephyr, which talked a bit about some of the difficulties of integrating TCP IP offload engines into Linux, and the kind of problems that we would face here are pretty much the same ones. It's basically requires a lot of work to go through the networking IP stack and find all the places where you want to offload, not just the data plane, control plane, but other things like the secure socket support, cryptography. Different chips offload different things. The TI chip happens to offload a whole lot of stuff. Other chips offload only some things. And then how do you get everything to work together? So that's it. Okay. Yes? Pardon?
So will you open source for the overload image? I mean, for the overload software, will you open source that, or you just release for binary?
Okay, so in our case, the host driver is open sourced. We just relicensed it. Mm-hmm. So this driver here is open source, okay. But the TCP/IP engine that's on the offload chip is closed.
Okay. So second question is Atmel or ST these two Wi-Fi is still overload the other stack into the different microcontroller or running single microcontroller for the Atmel and ST?
ST, it's using a different chip, for the offload. It's not on an SoC.
Okay, that is same with TI's chip, right?
TI is, we have two solutions. We have both.
Yeah.
We do it on an SoC with a CC3220, and we have a CC3120 where we offload to a
Okay.
different chip.
Okay. Okay, got it. Thank you.
Okay, you're welcome. Good. Do you want a laser or?
Show me what to press, like this. Oh, okay.
Yeah, yeah. So forward, back.
Okay, hi, my name is Paul Sokolovsky, and the next lightning talk is about general Zephyr networking status, and in particular about BSD socket state. So since last Connect last autumn in San Francisco, there were 2 Zephyr releases, and here's a high-level overview about notable networking changes in them. So 1.10 added explicit loopback interface, which is useful first of all for testing. Almost all application-level protocols like MQTT, HTTP were switched to current official net application API in Zephyr, so there is consistency how they implemented. New HTTP API, like version 2 of API redesign, was merged, which should be more flexible than the previous version, which was kept in 1.10 but removed in 1.11. And 1504 6LowPan fixes were applied, and it's known to work, for example, on Freedom board KW41Z. In 1.11, which was released like a couple of weeks ago, OpenThread support was merged. As far as I know, well, there is actually PR for Freedom board, but initially it was tested on NRF52. IPv6 Ethernet multi-custom requirements were fully implemented, so we should comply with related RFC, but it showed some issues with other IPv6 BRS, like 6LowPan, need some kind of optimizations. Static IPv4 configuration was enhanced, so now it's possible to pre-configure static addresses, so the device could be connected directly, for example, to a laptop or as a computer, and at the same time, if the DHCP is available, for example, if the device connected to router, it would override those settings. And new net buffer allocation code was merged. It actually coming from Bluetooth subsystem, so it's not yet used by IP stack. So plans for 1.12 is, first of all, it is supposed to be a long-term support release. As just an engineer, I have no idea if it actually will be, because we still have many things in flux, but yeah, so there is definitely some stabilization work is planned. Core team from Intel works on pretty advanced things as for IoT-related RTOS. For example, it's VLAN and traffic classification supports with kind of Linux style. I'm not sure about the requirements, but yeah, they seem to be serious about multi-interface, network interface support. And as previous presentation by Gil shows, there is work, a lot of accumulated for Wi-Fi support, and hopefully it will be merged in this next version. Yes, so there is idea to switch application protocol implementation to BSD sockets, and work undergoing to show that it's a viable approach. This new net buffer allocation code hopefully will be leveraged for IP stack. It offers some interesting capabilities. For example, zero copy working with roamable read-only code, like no need to copy data from flash to be sent over network. And yeah, there are still work to be done on like debugging and making sure that IP stack is reliable. So in particular, there are following known issues. So there are some deadlocks still seen, especially well on the high load when we start to test, like load testing, and in particular, there are allocation issues, like in some cases, infinite timeouts are used for location, and it can lead to deadlock. Another issue is possible there are concurrency issues. Yeah, other area to do more testing is performance, especially TCP performance. So initially, Zephyr was optimized for UDP, for simple networking protocols. So TCP performance is not ideal. And again, trying to test drivers, specific network devices drivers under high load shows that there are issues in such mode too. Yeah, other issue is correctness of current net app-based application level protocol implementations, especially TCP-based. And if you switch to BSD sockets, it should be like automatically resolved. Yeah, and most like low-hanging issues were already fixed in those recent versions, and these remaining issues is a bit hard to test. So we need to improve testing framework. For example, we probably need to introduce some fault injection framework to be able to catch this. Yeah, and some tracing evolution of BSD sockets API, which I initially authored and maintained. So it was merged in 1.9, and just what kind of changes or fixes were applied to it recently. So there are work on making sure that we have correct POSIX semantics for individual like details of calls, for example, how arguments are handled. Of course, better error handling. We find cases where there are resource leaks on errors and not exactly correct error handling. Not blocking sockets is more or less complex area. So there are many different ways to use them, and initially implemented is just one way, one simple way, and people start to leverage it and find issues. So some fix was merged recently. We need more tests for networking in general and sockets API in particular, and recently again a test sample application was merged which downloads long big files like few megabytes, 10 megabytes, whatever, over HTTP, and it checks that everything is correct and the load is correct. So for leveraging socket API, we need more infrastructure. First of all, TLS support and RFC PR for that also was posted. We need also port more helpers from net app interface. And that work is ongoing. It's, for example, as Gil mentioned, MQTT library was ported to both sockets and TLS support. And currently the biggest open source application to show BSD sockets, how it works, and to play with it remains is Micropython. People start to leverage it. Yeah, I'm sorry, we were delayed to just 10 seconds. And people start to leverage BSD sockets API, but seems like it's mostly in-house applications. So we're asking people, what do you use BSD sockets? Tell us, but they say we port some existing code. So if you're interested in BSD sockets for Zephyr, it's Micropython currently, very easy to use. Thank you. Maybe there is a very quick question. I'm sorry, guys, we were delayed for 8 minutes. Any questions? No, thank you.